for flow barriers, which other people might call leaky weirs. In the UK, midstream weirs retain 61 metres cubed of water, reduced peak flows by 16.6% for 1 year events. In Mexico, gabion structures decrease peak flows by 46% for 10-year events and 13.6% for 100-year events. And as you'll hear, in Australia's Pomona catchment, our modelling showed that effectively configurated leaky weirs reduced downstream urban flood depths by an average of 30%. So Pomona is a town in Queensland, southeast Queensland. It's a lovely, beautiful place near quite a touristy area, but it does have quite serious flood issues. And in working with the local government area for Pomona, we identified that this was one of the places they were really worried about flooding from rivers. So our guidelines are all about riverine flooding and particularly how we can reduce riverine flooding in towns and cities through a catchment approach, because what's been proven is that just taking an urban nature-based solutions approach often, usually, almost certainly won't address quite serious river flooding problems. And so you need to actually reduce the flooding from the river at its source rather than just at the end downstream. And so we've put a lot of effort into identifying these catchment-based solutions. And in Pomona, they have dangerous water levels over roads, they have inundation of the sewer pump station, they have inundation of their electrical substation, and local businesses and houses are also impacted. And so after going through what we call an option design and analysis process, we came up with leaky weirs, which are those flow barriers I talked about earlier, as an approach to reducing flooding in the Pomona catchment. So there are quite a lot of streams and a river that goes through Pomona. And so leaky weirs can control overflow during high flow events and prevent uncontrolled flooding downstream. They also reduce erosion and sedimentation. They enhance the connection of the river with the floodplain, which is a really important element of nature-based solutions. And the only thing about leaky weirs that's really difficult is modelling them is really tricky. So doing hydrodynamic modelling of large numbers of leaky weirs is problematic. So we took this approach of doing a small number of leaky weirs and then extrapolating to what would it be like for large numbers. But obviously, if this was something that this catchment ended up wanting to do, they'd have to do a lot more detailed modelling. There are a lot of co-benefits of leaky weirs. There's groundwater recharge, maintenance of environmental flows, habitat diversity. Often if you design them right, you get fish passage. They're very low construction costs compared to something like a large wetland construction, and a lot less maintenance than some other approaches, but they still do need to be maintained. So this was what happened in a AEP flood of 20%. And you can see that those 7 leaky weirs actually did have quite a big impact on the inundation area. And what we did was we worked out how many leaky weirs of 1.5 metres high you would need to achieve the same impact of 7 big leaky weirs for different AEPs. At an AEP 20%, instead of having those large leaky weirs, which were high, you'd need 54. But if you wanted to try and address a flood that was much, much bigger, say a 1% flood, you'd need 112. And we think that you could potentially try addressing a really big flood of 0.05% by 179 leaky weirs. But of course, that would really need to be tested because that's very optimistic, probably.